Hi folks, Raspberry Pi 6 might be just around the corner. However, the competition is fierce and they have already launched competitive products. The situation seems to be the same as the one before launching Raspberry Pi 5. We all know that we got Orange Pi 5 a few months before Raspberry Pi 5. In the last October, a proposal of Raspberry Pi 6 was published on GitHub. It proposes a different connector configuration with a full-sized HDMI port and 2.5 gigabit per second Ethernet controller, as well as 16 GB of RAM. It proposes an 8-core CPU and two PCIe Gen 3 connectors. The first one is Raspberry Pi 5 compatible, so you could use the same heads. And the second one is M.2 Type M connector for fast SSD drives. I guess it could also be used for connecting external graphics cards. An 8-core CPU system on chip is proposed, so many think that this could be Qualcomm's Cryo processor. Other features would have mostly remained the same, though there would be some changes to connector positions, and one of the USB ports would have been omitted. There is also no mention of USB 3.1 or USB 3.2 or even USB 4.0 ports that would also be used to connect an external graphics card. And now to the interesting part of this story. This design is strikingly similar, at least visually, to the design that was introduced on one of the Chinese developers conferences on 17th of April. Radxa Dragon Q6A single board computer, though it's USB Type A Ethernet connector and power over Ethernet connector arrangements, as well as audio jack that has returned, are the same as on Raspberry Pi 4. It also features a full-sized HDMI port on the same place as on the Raspberry Pi 6 proposal. There is also Wi-Fi 6 and Bluetooth 5.4 controller with two external antennae connectors, instead of Raspberry Pi 5's external one-lane PCIe port. There is an M.2 connector for SSD drives, though it doesn't officially support lengths over 2042. It could also probably be used for larger SSDs if there was a special mount in a larger case. The board also features 4 MIPI connectors for external cameras and displays. Two of them are 4-lane and the other two are 2-lane. There is also a micro SD card slot, as well as external real-time clock battery connector and a microphone connector. There are also a couple of connectors for eMMC modules and unified flash storage modules, which are faster than SD cards but still much slower than SSD drives. There are 4 USB ports, 1 USB 3.1 and 3 USB 2.0. The 5th USB-C port is PD capable, but it's only used for powering. There is also a power input header that can be used instead. And now let's discuss the Dragon's heart. It's Qualcomm's QCS6490 system on chip with 8-core Cryo 670 central processing unit that, similarly to Qualcomm's Snapdragon, supports asymmetric multiprocessing. There are 2 groups of processing cores, one of 4 ARM Cortex A78 cores and the other one of 4 ARM Cortex A55 processing cores. 3 of A78 processing cores are running at 2.4 GHz, while the fastest one is running at 2.7 GHz. The group of 4 least capable cores, A55, that are running at 1.9 GHz can be viewed as a replacement for RP1 microcontroller that is also an integral part of Raspberry Pi 5. We already know this kind of core arrangement from Rockchip 3588 system on chip, which features the same A55 cores and A76 cores. Raspberry Pi's 2712 system on chip also features 4 A76 cores, but lacks less powerful A55 cores. QS6490 system on chip is built on 6nm technology, so there is enough room for hexagon tensor accelerator, which is mostly used for AI processing and features up to 12 tera operations per second, while Raspberry Pi 5 has no AI processing capabilities, without an additional Halo 8 or Halo 8L head, which cost around 200 and 100 euros respectively. The fastest Halo 8 can process up to 26 tera operations per second, while the slower and cheaper Halo 8L can only process about 13 tera operations per second. Let's discuss the final question. How does Radxa Dragon Q6A compares to Raspberry Pi 5 and forthcoming Raspberry Pi 6? ARM claims that A77 cores are about 20% faster than A76 cores at the same clock frequency. If we compare A77 cores to A78 cores, they are 7% slower than A78 cores. So we can quickly calculate that the difference between A76 cores at the same clock speed to A78 cores is about 28%. However, A78 cores can run at higher clock speeds because they are designed for chips with higher nodes densities. However, Qualcomm's system-on-chip QCS 6490 is not designed to enable overclocking. So Raspberry Pi 5 still has a large margin because you can easily overclock it to 3 GHz, just as I did. You can watch my video if you want to see how you can do it yourself. Radxa Dragon Q6A only has one 16GB memory chip, which is the same arrangement as Raspberry Pi 5. Therefore, I presume that it can mostly benefit from newer processing cores and a better graphics core. Adreno 643L is probably better than Broadcom's Video Core 7, and here there is a large margin for Raspberry Pi 6 and for Broadcom to build a more capable system-on-chip, probably marked 2713, to include a better graphics core as well as newer processing cores. There are also other contenders. For example, single-board computers with Intel N100 and N150 processors. They are on average 2 times as expensive as Raspberry Pi 5, but some new models are significantly cheaper while maintaining almost the same performance. Radxa X4 single-board computer features Intel's N100 processor and greatly simplifies implementation of Raspberry Pi's charismatic 40-pin expansion connector. Its schematics reveals that it uses Raspberry Pi's RP2040 microcontroller to implement the missing 40-pin expansion port functionality. RP2040 microcontroller is connected to Intel's N100 processor through an internal connection to a USB 2.0 port. It's interesting that Radxa X4 only costs about €90 with shipping, but similar design that is also based on Intel N100 and Intel N150 processor, but instead of RP2040 chip uses an FPGA array to implement 40-pin expansion port directly on PCIe bus. Costs around €300. There is also a more urgent problem. Many new mini and micro PCs with competitive prices are much more powerful than any kind of single-board computers that are ARM based or are made to provide general-purpose I/O ports. No matter what happens, Raspberry Pi 6 is currently probably too far in development to switch over to Intel or AMD processor, which would also require a radical change in design philosophy. On the other hand, I don't believe that Raspberry Pi would build Raspberry Pi 6 based on 9th generation of ARM processors like X4 or X925, or at least a 720 or a 520. These cores are made for more precise chip manufacturing technology with smaller processing nodes, like 4 nanometers. Though it would be very beneficial for Raspberry Pi 6 to incorporate a much more powerful AI accelerator than Halo 8 modules, it is more probable that they would rather go for about 20 tera operations per second, and they would rather do a complete overhaul on the graphics processing unit to include various accelerations, including those for decoding different video formats like H.264 or H.265. There is also an option of enabling simple 3D acceleration. Very interesting. Computer designs are also incorporated in NVIDIA's Jetson family of single-board computers. They usually have 4 ARM Cortex A78 cores packed together with a very powerful graphics core, which can be used for AI processing. But what really caught my eye and may have been missed by many computer journalists is Radxa Radxa Orion single board computer. They were taking pre-orders until the end of the last year. The computer is launching by the end of May. There are 4 variants with 8 GB, 16 GB, 32 GB and 64 GB of inbuilt RAM, starting at 190 euros for the cheapest version to more than 400 euros for the most expensive version. You also need an 8X power supply, the one that you can also use for a classics PC, or a 65-watt PD-capable power supply that powers the board through a USB-C port. You also need a special heatsink for the system on chip. But what is more interesting is what's inside it. There are 8 ARM Cortex 720 cores, 4 of which are running on 2.6 GHz and the other 4 are running on 2.4 GHz to lower the temperature profile. And there are another 4 ARM Cortex A520 cores that run at 1.8 GHz. Graphics core is ARM Immortalis G720 MC10 that supports hard ray tracing, Vulkan 1.3, OpenGL ES 3.2 and OpenCL 3.0. There are also 4 different display outputs available, which includes HDMI, DisplayPort 1.4, eDisplayPort through touch panel, and USB-C type with DisplayPort alternate mode. Neural processing unit can achieve up to 30 tera operations per second, and it supports precisions from 4 bits to 32 bits. There are also 2 MIPI interfaces that can work as a 4-lane or 2-lane interfaces. There are also 2 5 gigabits per second Ethernet port, which is also impressive because many desktop PCs don't have such a fast Ethernet port. 4th generation PCIe interface is 8-lane, though the connector is suitable for a card with 16 lanes. Imagine that you can connect here a proper graphics card. There are also 2 USB 3.2 C-type ports and 2 USB 3.2 A-type ports and 4 USB 2.0 ports. There is also an analog audio jack as well as a microphone audio input. The board has PC-like power on and reset buttons, as well as real-time clock battery holder. There is also an M.2 PCIe M-type port for an SSD drive of 2280 maximum length. Linux distributions are available for the board, as well as full UEFI support. The board measures 17 by 17 centimeters, so it's considerably bigger than Raspberry Pi 5, but also offers much more functionality. Though this board is very powerful, it is not as powerful as now 2 years old Qualcomm Snapdragon development kit for Windows, which costs around $900. However, this is an open hardware and open software board. Now you know what's the upper limit of ARM 64 Generation 9 architecture compared to Generation 8 architecture that is used with most of single board computers, also with Raspberry Pi 5. Considering the cost of this board, I believe that Raspberry Pi 6 is not going to be as powerful. It would probably be more powerful than Dragon Q6A single board computer, or it would at least have more functionality like double micro HDMI ports, or maybe a combination of single HDMI and USB 3.2 port with an alternate HDMI mode. What I really hope for is that Raspberry Pi 6 is gonna be more powerful than Intel N100 and Intel N150 processor. This would really give it an edge and would keep enthusiasts interested in Raspberry Pi design. Otherwise, who knows, if there is a number of cheap mini PCs, the majority of users may prefer them over Raspberry Pi in a few years. Thank you for watching. If you've liked this video, please press like and subscribe buttons and don't forget about the notification bell. See you in the next video. Bye.